We'll begin by exploring testing and debugging techniques essential for MERN stack applications. This module focuses on ensuring the high quality and reliability of your modern web applications. Let us understand why software testing is absolutely crucial for robust software development. It is critical for building robust and highly reliable applications that meet user expectations. Firstly, testing plays a vital role in ensuring the overall quality of your software. It helps detect and resolve bugs effectively well before any deployment. Moreover, effective testing actively prevents potential failures from occurring within your applications. This avoids costly fixes and extensive rework once the software is released. Good testing practices also significantly improve the security posture of your applications. It helps identify and address potential vulnerabilities before they can be exploited. Ultimately, comprehensive testing greatly enhances the overall user experience of your software. This ensures your application consistently delivers smooth and reliable performance for users. Now, let's explore the various key types of software testing methods available. Each testing type is designed to validate specific aspects of your application thoroughly. First, we have unit testing, which is fundamental for isolated checks of small components. It specifically tests individual components of your code, such as functions or modules. Next, integration testing focuses on how different parts of your system interact. This ensures that all components work together correctly as a cohesive system. Functional testing then verifies if the application behaves exactly as expected by users. It checks whether the application meets all of its specified functional requirements. Performance testing is crucial for evaluating how your application handles various workloads. This measures its speed, responsiveness, and overall stability under various conditions. Security testing is vital for protecting your application from potential threats and vulnerabilities. It actively identifies potential vulnerabilities and weaknesses present within the system. Finally, user acceptance testing, or UAT, validates the software with end users. This ensures the software truly meets the business needs and user expectations effectively. Now, let us compare manual testing versus automated testing approaches in software development. Both are strategic choices for achieving efficient quality assurance in your projects. Manual testing, as its name suggests, involves direct human effort in execution. It is performed by individuals without the aid of any automation tools. This approach is often best for validating user interface, user experience, and exploratory testing. On the other hand, automated testing uses specialized scripts and various tools. It runs tests automatically, which can be much faster and more consistent. Automated testing is ideal for regression, unit, and performance testing scenarios efficiently. Let us now look at specific testing tools for the MERN stack. These are tailored solutions designed for each layer of your application. For front-end testing in React, we primarily use two powerful and effective tools. Jest and React Testing Library are excellent for testing individual components thoroughly. Additionally, Cypress is a robust choice for comprehensive end-to-end UI testing. Moving to back-end testing with Node.js and Express, we have other options. Mocha and Chai are commonly used for API and integration testing purposes. Supertest is also a great utility for testing HTTP requests very effectively. Finally, for database testing with MongoDB and Mongoose, a specific tool exists. Mongo Memory Server allows you to perform in memory MongoDB tests efficiently. Let us get an overview of Jest and React Testing Library, two important tools. They are powerful tools for creating robust tests for your React components. Now, considering Jest features, it offers several distinct advantages for developers. Jest provides fast and easy setup, simplifying your testing workflow significantly. It also supports data mocking, allowing you to isolate tests from external dependencies. Moving on to React Testing Library, it focuses on slightly different testing aspects. It facilitates writing user-centric component tests, simulating real user interactions. This approach helps avoid relying on specific implementation details of your components. Here, we will look at a Jest unit test for a very simple function. This demonstrates verifying core logic effectively using Jest's powerful expectation methods. First, let's examine the sum.js function, which is quite straightforward. This function takes two arguments, a and b, and returns their sum. It is also exported for use in other modules. The code defines a sum function that adds two numbers and exports it. Next, we have the sum.test.js file, which contains our test. The test function defines a test case, while expect checks if the output matches expectations. To be 5 verifies the sum. This test imports the sum function and asserts that 2 plus 3 equals 5. Here, we will conduct unit testing on a simple React counter component. We will simulate user interactions using the React testing library very effectively. Let us first look at the counter.js component definition in our example. This simple React component displays a count and includes a button to increment it using the doState hook. The code defines a functional component displaying a count and an increment button. Next, let us examine the counter.test.js file for the test case. Render mounts the component, screen.getByText finds elements, and fireEvent.click simulates interaction. Expect asserts visibility. This test renders the counter, clicks the button, and then verifies the count updates to 1. We will now demonstrate an end-to-end login functionality test using Cypress. This allows us to simulate a complete user login journey within the application. The first step involves navigating directly to the application's login page, URL. The command cy.visit directs Cypress to the specified local host login, URL. Next, we need to enter the email address into the appropriate email field. cy.get selects the email input field and then type enters test at example.com. Following that, we enter the password into the designated password input field. This command selects the password input and types in password 123. After entering the credentials, the next action is to click the login button. cy.get locates the submit button and then click simulates a user interaction. Finally, we verify that the user is successfully redirected to the dashboard page. cy.url should confirms that the URL now includes /dashboard. Now, let's discuss some effective debugging strategies for your MERN stack applications. These are crucial tools and techniques for MERN stack error resolution. First, browser developer tools are incredibly useful for effective front-end debugging. They allow you to inspect the UI, network request, and component state. Console logging is a straightforward yet powerful technique to track function execution and data. It helps track function execution flow and inspect data at various points. Implementing proper error handling like try-catch is essential for application stability. Using try-catch blocks helps prevent unexpected crashes and provides graceful error recovery. Dedicated debuggers offer more advanced control over your application's code execution. They let you step through code line by line and inspect variable values. Finally, external API tools are invaluable for effective backend debugging. Tools like Postman allow you to test API responses independently and efficiently. To summarize this module, let us review the key takeaways for effective learning. These points are essential for understanding MERN stack testing and debugging. Software testing ensures application quality, prevents failures, and enhances the user experience. Unit, integration, functional, performance, security, and UAT are all essential testing types. Remember, automated testing is generally faster and more reliable than manual for large applications. Jest, React testing library. Cypress, Mocha, Chai, and Supertest are key MERN testing tools. Debugging involves identifying and fixing various errors, including syntax, runtime, and logical bugs. Browser developer tools, console.log, try-catch, and dedicated debuggers are crucial for error resolution.